Yes, now we take differentiation of inverse trigonometric functions. Okay. Inverse trigonometric functions like sine inverse x, cos inverse x, tan inverse x, etc. We'll take one of them at least and explain how you get the results, and then we will take more problems. So let's talk about y is equal to sine inverse of x. When we say y is equal to sine inverse x, you can also say that this sine y is equal to x, all the same thing. And then when you have to differentiate with respect to x, you will get sine y will become now cos of y, d dx of sine x is cos x, so d dx of sine y will be cos y. But since it is not x, it is some other variable, you need to write here that dy dx also equal to d dx of x with respect to x, which is 1, right. And now you got dy dx equal to 1 upon cos of y. And how you can obtain the value of cos y from here? So for this you need to draw a triangle. We are saying here sine of y, that is this angle is y and its value is x. Either you say it's x or you say it's x upon 1, all the same. Perpendicular upon the hypotenuse, x and 1. So actually it should be only the ratio, but that will also give the same. So we are not going to that detail. Pythagoras theorem gives us 1 minus x square. And therefore, when you have to obtain the value of this 1 upon cos y, for cos y now you can say base upon the hypotenuse. Base upon the hypotenuse. So you can say this is root of 1 minus x square upon 1, or else simply 1 upon root of 1 minus x square. We have obtained this value of dy dx, okay, or you can say d dx of y, and what is y? Sine inverse of x. You write here d dx of sine inverse of x, and therefore we have obtained a value of derivative or differential coefficient of sine inverse of x, which is equal to 1 upon root of 1 minus x square. Similarly, we can find the ratios for derivatives for other ratios, other values also. But here there were certain restrictions that too we should mention here. We know that the value of sine inverse x, that angle lies between minus pi by 2 to pi by 2. I hope you all understand that the value of this sine inverse x, which is the angle, it lies between this interval minus pi by 2 to pi by 2, or else you can say this value of x should belong to the interval minus 1 to 1. And here you are saying that 1 minus x square. So this confirms here that the values of x which will lie between minus 1 and plus 1, this root will always give you some real number, because if imagine that if that x goes more than 1, if it was possible, 1 minus a number which is greater than 1 will give you a negative value, and root of that negative value will not be a real number. So that restriction is essential to be stated here, that x will be between minus 1 and plus 1, therefore this will remain positive, and therefore you got this standard formula. Derivative or differential coefficient of sine inverse x is equal to 1 upon root 1 minus x square. Same way you can try others also, just I am recollecting them, or I am just putting them here before we go to the questions from the exercises. So you got first one, that d dx of sine inverse x is equal to 1 upon root of 1 minus x square. We have obtained that, shown here. Similarly, second, d dx of that cos inverse x comes to be same numerical value, 1 upon root of 1 minus x square, simply with a negative sign. You can see, you can learn them or keep in your mind easily that the numerical values are same, and derivative of cos inverse x is minus 1 upon the same thing. And I'll show you one more relation that why it comes like that. But before that, let me collect these formulae. d dx of tan inverse of x is equal to 1 upon 1 plus x square. You can try them the same way and obtain this result. Fourth, d dx of that cot inverse x, same expression 1 upon 1 plus x square with a negative sign. So you can see these are pairwise. d dx of sine inverse was this, d dx of cos inverse, same thing with the negative sign. Similarly, d dx of tan inverse is this, d dx of cotan inverse, that is cot inverse x, is same thing with the negative sign. Similarly, two more. 5, d dx of sec inverse x comes to be 1 upon x root x square minus 1, and in order to keep this expression as positive, we put a modulus sign, absolute value sign. And same way, sixth, that is the last in this, d dx of this cosec inverse x, same expression just with the negative sign. So minus 1 upon x with the absolute value sign, and the same expression x square minus 1. Remember that here it was 1 minus x square, and this one is x square minus 1, and this is also x square minus 1. And this also comes with a pair. Sec inverse and cosec inverse, whenever there is you got a minus sign. Tan inverse x and cotan inverse x, same thing with the negative sign. Sin inverse x and cosine inverse x, same expression with the negative sign. So these are standard results. Now we will take questions.